Hey, it's Neil from Grade Savers, and today we're doing question number 35 from section 7.1, which deals with solving integrals by substitution. So this question is a bit of a tough one. The question reads, what is the integral of x cubed root 5 plus x squared? Now, normally people would use u as x cubed, so we would find our dx would be equal to du over 3x squared, and then we'd start our substitution and we'd see we can't get too far. There's no way to get rid of the x variables. So let's try u equal to root 5 plus x squared. That means it's equivalent to 5 plus x squared to the power of a half. Then we can find our dx to be equal to du over the derivative of u, which in this case by chain rule will be 1/2 5 plus x squared to the power of a negative half times 2x. And it turns out these two cancels out, and we can simplify by bringing this negative exponent into the numerator. So we get 5 plus x squared to the power of a half du over x. And now we can begin substituting our values in. X cubed cannot be replaced with u or dx, so we can keep it there. The root 5 plus x squared can be replaced with u, and our dx is replaced with 5 plus x squared to the power of a half over x du. Now we can see one of the x's cancels out here, so we're left with the integral of x squared. And this 5 plus x squared to the power of a half is also equivalent to u, so that's where we get the second u from. So this integral simplifies down to the integral of x squared u squared du. The problem that still lies here, though, is that we still have an x squared here. So here's one way we can get rid of the x squared. Let's go back to our original equation for u. We stated that u is equal to root 5 plus x squared. So let's solve for x squared. And it turns out that x squared is equivalent to u squared minus 5. So now we can substitute for this x squared value, this value, which is in terms of u. So that's how we get the integral of u squared minus 5 times u squared du. And now we can expand this out. So we get u to the power of 4 minus 5u squared du. And these integrals are very easy. This simply becomes u to the power of 4 plus 1, which is 5, divided by that new exponent, so divide by 5, minus 5 times u to the power of 2 plus 1, which is 3, divided by 3, plus our all-important constant. And now we can combine and get a common denominator, so this becomes 3u to the power of 5 minus 25u to the 3 over 15. The way I got this was our common denominator will be 15, 5 times 3. So I need to multiply and divide this by 3, multiply and divide this by 5, and our constant c remains. Now I can factor out u to the power of 3, so we're left with 3u squared minus 25 over 15 plus c. And now we can substitute in, finally, for what we chose our u to be. U was equivalent to 5 plus x squared to the power of a half, or root 5 plus x squared, whichever you prefer. And we can begin simplifying. So here are our substitutions in gray. And one of the rules is a power to the power, so let's say it was a to the power of m to the power of n, is equivalent to a times m to the times n. So that's what we're doing here. That's how we go from 5 plus x squared to the power of a half to the power of 3 is simply 1/2 times 3, which is 3 over 2. And here, 1/2 times 2 is just 1, so we're left with 5 plus x squared. The next step is to open this bracket up so we can simplify. So we get 15 plus 3x squared. That's how we got this, minus 25. Everything else remains the same. And we can simplify by adding this 15 and this negative 25. So we get 5 plus x squared to the power of 3 over 2 times 3x squared minus 10 all over 15 plus our constant c. Like I said, this is a pretty tough question, and it might take a few minutes on the test. And good luck. Take care. Hey, thanks for watching. Grab the PDF from below, and remember the best way to study is to join the Grade Savers review sessions.